Okay, here we go. So, before we start, I just want to do a couple of these from what we've already learned. Let's do the tangent of a negative 300 degrees. Tangent of a negative 300 degrees. Negative 300, you go in this direction, don't you? To go a negative 300. And you stop about right here. Some of you are drawing your line to the y-axis. You never draw it to the y-axis. You always draw it to the x-axis. If you went 300 degrees all the way around here, this angle in there is called the reference angle, and you went 60 extra degrees to make that triangle or that reference angle. This is the square root of 3, this is 1, and the hypotenuse is 2. And if they want you to do tangent, tangent is y over x. It's nice to have that formula sitting there. And the y in this problem is the square root of 3. And the x in this problem is 1. What are we doing today? They're giving you this. You have to find the angle. They give you the ratio, and you have to find the angle. You need to know a little, like the square root of 3 works with the 30, 60, 90 type of a triangle, doesn't it? The square root of 3. You need to know that a square root of 2 works with the 45, 45, 90 triangle, right? You need to know that when you land, if they ask you to find the sine of 90 degrees, or cosine of 90 degrees, cosine of 90 degrees is x over r. The x is 0, and this is really, the radius is always what? When it doesn't make a triangle? What's the radius always? 1. So when you get an answer of 0, you need to know it doesn't make a triangle, it makes one that lands on the 0, 90, right? So you have to be very familiar with what type of an answer you get and what type of an angle it could make, right? So, sine, cosine, and tangent are all positive in the first quadrant. Sine, cosine, and tangent are all positive in the first quadrant. Its reciprocals are also positive. What I mean that? The reciprocal of cosecant is positive, so that's also positive. The cosine and the secant are also positive. The cotangent and the tangent are also positive in this quadrant. In this quadrant, the sine is positive, the cosine is negative, and the tangent is negative. Once again, they're reciprocals. If the tangent is negative, the cotangent is also negative in this quadrant, right? I'm only giving you these 3, but the reciprocals also work with that. In this quadrant, the sine is negative, the cosine is negative, and the tangent is positive. And in that quadrant, the cosine or the sine is negative, the cosine is positive, and the tangent is negative. So, somebody came up with this a long time ago, a little saying that helps you remember all of these. All students take calculus, which isn't true. Not all students take calculus. All. Sine, cosine, tangent are all what? Positive, correct? All students. Student has the letter S. Notice that the one that starts with the letter S is the only one that's what? Positive. All these are positive. Only the one for students, S, is positive. Take starts with the letter T. What's the only one that's positive in the third quadrant? Tangent. Calculus, the only one that starts with the letter C is cosine. That's the only one that's positive. All students take calculus. It's an easy way to remember which ones are positive and which ones are negative. Another way to do this, I don't want to tell you another way. That's good. Okay, let's just start. Number one, solve from 0 degrees to 360 degrees. You're trying to solve for x. You're solving for the degrees. They give you the ratio. As you can see, they give you the answer like you had on the test. We have to come up with the degrees. What's the tangent of how many degrees will give you 1? The sine of how many degrees will give you 1/2. So you draw yourself a picture, just like you did on the last test. You want a positive answer, don't you? Right? All, this quadrant, the tangent is positive, isn't it? All of them are positive in that quadrant, aren't they? All students take calculus. Take is tangent. That one's also positive in this one too. Tangent is positive in those two quadrants. They want two answers because they want the answers from 0 to 360. So they want two answers in this problem. What's tangent? What's the formula for tangent? Formula for tangent? Y over x. It's not written like that, but isn't 1 the same thing as 1 over 1? Isn't 1 the same thing as 1 over 1? If the x is positive and the y is positive, and this is your reference angle, y over x, does that make the tangent? And this quadrant also. What is this one going to be right here? -1. What is this one going to be? -1. What happens if you're talking about the reference angle and you went y over x? Does that also be a +1? Right. What type of a triangle deals with two sides identical to each other? What's your reference angle going to be right there? 45 degrees. This angle is 45. This angle is 45. But the actual angle is not 45. If you're in the first quadrant, doesn't the angle have to be less than 90 degrees if you're in the first quadrant? Isn't it going to be 45 degrees in the first problem for the first one? And if I'm in this quadrant, the third quadrant, and I went past the 180 marker by 45 degrees, what's the actual angle in this? What's 180 plus 45 make? 225. I found the two angles that make equal 1. I found the two angles that make it 1. Basically, this is all we're doing. But for a lot of people, they struggle with this. They'd rather do it the other way, where they give you the angle and you find the side. It's easier to do it that way. Okay, let's do another one. There's two parts. This is the main part. The last part is you've already had already on the last test. I don't know why they're doing it again, but they are. But sine of x equals 1/2. Sine of x equals 1/2. I want to just see if I have any negatives. Do I have any negatives? Yes, good. I've got some negatives. Let's do a positive 1/2. All, sine is positive in this quadrant. All students, S, sine, students, positive. These are the two quadrants that your sine is positive in. The first quadrant and the second quadrant. Again, maybe you want to write your formula down. Sine is y over r, or 1 over 2. I'm going to label my triangles. My y value is 1 and my radius is 2. My y value is 1 and my radius is 2. You should know what kind of triangle it makes if you have a 1 and a 2, and I don't care about that, but it's root 3, isn't it? Isn't it root 3? So What's the side opposite of 1 going to be? 30 degrees. What's one answer to this problem if you're in the first quadrant? 30 degrees. The other answer also deals with the 30-degree reference angle, but it can't be the right answer because you are in the second quadrant. You went to make this line right here, you went all the way to here, but then you were short by 30 degrees to make 180. So what angle are we talking about in this quadrant? 150. And that's it. We'll just keep doing about 4 more of these, and that's about it. Cosine of x equals, let's change it up. We gotta change it up. Negative root 2 over 2. The cosine of x is equal to a negative root 2 over 2. Draw yourself a picture. Cosine of x is equal to a negative root 2 over 2. All, we're talking all is positive. We're not doing this quadrant, are we? All students, that's positive. So if students is positive here, that means cosine is negative here, correct? Cosine is negative in this quadrant. If tangent is the only one that's positive in this one, take, right? That means cosine is negative in this quadrant. Cosine is negative in this one and this one. Isn't cosine x over r? Right? The formula for cosine is x over r. We have a negative root 2 over 2 as our final answer. Our r is supposed to have a 2 in it, and our x is supposed to have a negative root 2 in it. We didn't study triangles that did this, did we? Did we study triangles that look like this? No, we did not study triangles that look like this. I'm going to reverse it. So, isn't this the same thing as a negative 1 over root 2? Isn't that the same thing as a negative 1 over root 2? But you can never leave a 1 in the denominator in math. A root, so what do we have to do to finalize our answer on the test? We had to multiply the top and the bottom by root 2. This is the x. This is the r. The x is a negative 1. The radius is root 2. Does that look better than what it was? Right, so you definitely have to know what it looks like before you simplified it. Most of you know that you're dealing with the 45-degree triangle by looking at this. So you know that your reference angles are both 45. But if they're both 45s, you are dealing with 135 for this one, correct? 135 for this one. And I went past the 180 marker to make this reference angle 45 degrees, didn't I? I went past the 180 marker, 45 degrees. So isn't the other angle 225 degrees for the final answer? You guys doing pretty good on these? Pretty good? Okay, here comes this one. Tangent of x equals 0. Well, it's not going to make a triangle because most of our answers had actual numbers on the sides of the triangle, right? So this must be a unit circle one, right? This must be a unit circle one. So I always do 1, 0, 0, 1, negative 1, 0, 0, negative 1. And I have to figure out which one of those two or 3 or whatever it's going to be. Tangent is equal to y divided by x. Tangent is y divided by x. I need to get an answer of 0. Sometimes your answer is undefined, isn't it? It's undefined when you have 0 in the denominator. It's not undefined when you have 0 in the numerator. The y has to be 0 for it to turn out to be a 0, correct? The y needs to be 0 for it to turn out to be 0. Can't x be 1 for it to turn out to be 0? Can't x also be a negative 1 for it to turn out to be 0? So where is your x 1 and negative 1, isn't it here and here at 0 and 180 to make it turn out to be 0? So 0 and 180. And they might try to trick you on the ACT on this type of a problem. Watch out for the stipulation. They want all of the angles from 0 to 360, including 0 and 360. Do you see the lines underneath it? Isn't 0 and 360 in the same spot? This one has 3 answers. 0, 180, and 360 for this problem because of the line underneath the 360. Okay, a couple more. How many more pages? 2 more after this one, or this one? Okay, good. And then this other thing that I gotta teach, okay. Okay, let's do the secant of x equals a negative 2 square root of 3 over 3. Secant of x equals a negative 2 square root of 3 over 3. I draw myself a picture. Secant is the reciprocal of cosine. I'm looking for all my spots where my cosine is negative. You're looking for all the spots where the cosine is negative. All, that's where they're all positive. Forget that one. All students, that's just positive for the sine. That means the cosine's negative in this quadrant. That's also negative in that quadrant because tangent is the only one that's positive in this one, right? 8. So, very similar. Cosine is x over r. So secant is r over x. You got to make sure you know your formulas. Cosine is x over r, so secant is r over x. If you look at your x, your r is not the negative. It's your x that needs to be a negative because you have a negative in your problem. Everybody see that? This negative really is going to be the x portion of it. And if you put a negative 3 here, that doesn't even make sense, does it? We've never studied triangles that have a side of a negative 3. This is in simplified form, isn't it? It should be written as a negative 2 over root 3. A negative 2 over root 3, because what happens when you multiply the top and the bottom by root 3? You get 2 root 3 over 3, which is, this stands for your r, and this one stands for your x. Your r is always positive though, so this needs to be a positive 2. It's this little guy that needs to be the square root of a negative 3, and this one a 2. Opposite of the reference angle must be that 1 then, right? The opposite of that reference angle is a 1. So the reference angle that we're talking about is 30 degrees right here, right? 30 degrees. The answer to the problem is not 30 degrees because I went this far, but I didn't go all the way to 180. I was short 30 degrees, so that makes it 150 degrees. And I went past the 180 marker by 30 degrees, which makes 210 degrees. Instead of doing cotangent, let's do sine of x equals a negative 1. Let's do that one instead. Sine of x equals a negative 1. Sine of x equals a negative 1. Sine needs to be negative. Sine needs to be negative. It's not negative there. All students, this is positive there, take calculus. It's only tangent and cosine that are negative here. So it's these two quadrants is where sine is negative. These two quadrants. So first thing I do is draw yourself a picture of where the sine is negative. I write my formula down, y over r. This ends up being a negative 1. So a negative 1 over 1 needs to equal the y and the r. Is there a triangle that we studied where the y and the r were the exact same number? Did we study one where the y and the r were exactly the same number? The x's and the y's were the same number, but not the y's and the r's. So it can't be a triangle, can it? It can't be a triangle. So all that thinking about which quadrant it was a waste of time, but at least I figured out that the y and the radius is, we never learned a triangle like that. So it must be landing on here. I've seen people who don't know how to write ordered pairs either. This is a circle. Some people think this point up here is 1, 0. It's 0, 1. Some people don't know how to write the points, which is important. Your y is a -1. Which one is it that your y value is a -1 at? Isn't it down here? Your y value is a -1. Your radius of this circle is always 1, isn't it? The radius of the unit circle is always 1. So it's definitely, the only answer to this problem is 270 degrees, is the only answer to that one. Sine of x equals a -1 at 270 degrees. You've got a lot of these to do, so you guys, I can do more. Do you guys want me to do more? You guys kind of get the idea. There's a lot of thinking going on though, right? You got to figure out which quadrant. You got to decide if you're making triangles or no triangles. You have to, we've never studied this. You have to put it back into that form and all that. So this will take time. And then the last template, this is again on the next test. It tells you that angle C is 90 degrees. It tells you that little side C is 9.8. It gives you angle 14 as angle A. On the last test, you found a side. On this test, you have to find all the remaining parts of the triangle. That's the only difference. We're missing, we know everything about C. We know angle C, we know side C, it's opposite. We know angle A is 14. We don't have to write that down. I don't know why I wrote that down. We need to find angle B. But if you know that this is 90 and this is 14, and you know that triangles add up to 180 degrees, you can add these two up and subtract 180 to get the angle B, correct? Which is 14 and 90 is 104. 76 degrees. I still have to find side A in the problem, and I also have to find side B in this problem for the test. Your choice. You can do whatever sine or SOHCAHTOA you want. We're trying to find side A, which is right here. You can do, I would do sine, because over here, you would do the sine of 14 degrees. Here's 14 degrees. Isn't the sine of 14 degrees the sine opposite over the hypotenuse, or A over 9.8? So in order to get A, all you do is take the sine of 14 on your calculator and multiply it by 9.8, and you are going to get the sine of 14 degrees times 9.8. You're going to get 2.4 for this one, which is this side right here. And then you have to find side B. You can do a squared plus b squared equals c squared if you really want to use the Pythagorean theorem, but they really don't want you to use the Pythagorean theorem. They really want you to find side B by maybe doing the cosine of 14 degrees. The cosine of 14 degrees is the side adjacent B over the hypotenuse. You don't have to use cosine. I could have used sine of 76 degrees, which is the side opposite over hypotenuse. I could use whatever trig function I want to find the missing sides and angles. Got it? I don't know. Do you want me to finish it? I'll finish it. The cosine of 14 times 9.5. This is 9.5. If you have time on the test, you could do a squared plus b squared should equal c squared, right? If you had time on the test, you could check it. So, a worksheet day today again on all of these.
I should sit in the chair.
Let me just do something quick here and then.